your success in this section really is going to be dependent upon your ability to understand the terminology so that you can remember what it is that you're supposed to be doing. And so I'm going to try to help you with that. First of all, integer exponents are exponents that are integers. 2, -2, and 0 are all integers, but what we're really going to be focusing on here is rational exponents. Rational exponents meaning that we have a rational number that is the exponent. Any integer divided by another integer is a rational number. And so what I want you to focus on here is we've got this line right here, and that line I want you to consider that separates the numerator obviously from the denominator. But I want you to think of that as the ground. All right, so we have the ground, and then underneath the ground, that's where the roots grow. So it's like, where do we put these numbers? That right there is where the roots grow. Roots grow under the ground, and roots are the ones that we say like right there. Like when we talk about numbers like the cube root of x, or the fourth root of 5 and things like that, or the square root even of, let's say, 2x. So we always say root when we say that number right there. And so that number right there, that under the ground, that's where roots grow, and that's where we're going to put, when we have a rational expression here, in exponential form, we have a to a rational exponent. We can also write that as in radical form. So one thing that is not on this page, hopefully you've printed out the page, this is radical form, and radical form would be either one of these forms here, this form or that form. Both have a radical in them, and we call that radical form. So if you have to find simplest radical form, then you'll simplify, and I'll show you how to do that, expressions that have a radical in them. This right here, this guy right here, is what we call exponent form, or in some places you'll see exponential form. So either one, when we're dealing with rational exponents, that's exponent form and that's radical form. So it'll specify exactly what you're supposed to, how you're supposed to express your answers. So I just wanted to make sure you understand that. So I think one thing would be really helpful is to just understand the difference here, and just to kind of see some examples before we do some of the examples here on your page. And I want you to make 2 columns over here to the right. We're not going to need a lot of space over here, but I want you to write exponent form, and then I want you to write radical form. And go ahead and we're going to make a couple columns here. Exponent form would be things like 7 to the 1/3, or 8 to the 1/3, or 8 to the 4/3, and things like that. These are all numbers to some rational exponent, even 6 to the -1/2, or even x to the 1/2, and things like that. That's what we call exponent form. And then if we apply what we just learned, that you can rewrite exponent form in radical form, either one of these. Let's just kind of do a few quick ones here. 7 to the 1/3 is the same as the cube root of 7 to the 1st. And we don't even need to write the first power. We can just write cube root of 7. And so cube root of 7, that would be simplest radical form. We can't simplify that anymore. 7 is not a perfect cube, so 7 does not have a perfect cube root. Although, on the other hand, we can write 8 to the 1/3 as the cube root of 8, and we've already learned that the cube root of 8 is 2. So we can do that. We can also take this 8 to the 4/3, and we can write that as the cube root of 8 to the 4th power. So if you notice, right up here, we can see we can include the power inside the radical like that, or we can write the power outside of the radical, which in this case makes it really nice, because if we want to simplify this expression, we would just go ahead and simplify cube root of 8, and we know again that the cube root of 8 is 2, and we would write 2 to the 4th, and we know that 2 to the 4th is equal to 16. And so we can simplify this exponent form by rewriting the exponent form using radicals and then choosing the better of the two. Now, when I say the better of the two, I mean let's try to keep our numbers small. If we do the cube root of 8, calculate that first and calculate that the cube root of 8 is 2, and then raise that number to the 4th power, that keeps things a lot smaller versus trying to figure out what is 8 to the 4th power. Well, you might go 8 squared is 64, and 64 squared, most people aren't going to know that right away, and then trying to then take the cube root of whatever 64 squared ends up being, but we'd end up getting 16. So if we try to keep our numbers small, we can do that by moving the power to the outside and calculating the cube root first, or whatever root we're trying to find. Now we know that when we have negative exponents, we can write those as positive exponents as long as we move. If the negative exponent is in the numerator, we move it to the denominator. So we'd have 1 over 6 to the 1/2, and then we would write that as 1 over radical 6. But then we know we can't leave a radical in the denominator, so we'd multiply top and bottom by radical 6, and we would get radical 6 over 6. So these are all some things that we should be able to do pretty quickly, and when you see these a lot, then you become more comfortable. And again, then x to the 1/2 in exponent form can be written as the square root of x in radical form. So I'll leave that for the first video, and then I'll pick up with the examples in the next video.